Welcome to my YouTube channel ErudiSpace. I am Dr. Mohanty, and today I will prove that energy is a property of the system. For proving the energy as a property of the system, first we should know what is a property, then what is a point function, and how the properties are point functions, and then we will apply the first law of thermodynamics for a closed system, both when it is undergoing a cycle and when it is undergoing a change of state. Any system has certain characteristics by which its physical condition may be described. Pressure, volume, temperature are the known properties of a system. Now we have to prove that energy is a property of the system. To prove energy a property of the system, we have to prove that it is a point function. So what is a point function and what is a path function? All the properties are your point functions. That means at a particular state they have particular values. We can discuss this with a specific example. For that, let us consider a PV diagram and consider two states, 1 and 2. Now, suppose consider the case of pressure. Pressure at point 1 has a specific value, and pressure at point 2 has another specific value. So when it is following a path, this path, it is passing through a number of intermediate stages. But when we have to find out that what is the change of pressure, this path has no bearing on that. You can follow this path, you can follow this path, you can follow this path, you can follow any path, but as far as the change of pressure is concerned, it only depends upon the initial and final points. The same is about volume also. Now, point function means it represents property, and properties are point functions. Now, we will prove that energy is a property of the system. So for that, let us take a specific example that would help us in proving that the energy is a property of the system. Let us consider a state 1 and a state 2. Suppose it is following a particular path represented by 1x2. Let us consider another path 2y1. Now, at the end of the second process, as initial condition is restored, it is said to execute a cycle. So in fact, processes 1x2 and 2y1, they constitute a cycle. And all of us know that as for the first law of thermodynamics, for a closed system undergoing a cycle, the summation of heat transfer is equal to summation of work transfer when they are represented in same units. Now, what are the heat transfers? You may consider Qx for 1x2 and Qy for 2y1. Similarly, for work transfer, you may consider Wx representing the work transfer for 1x2 and Wy for 2y1. Let it be equation 1. Now, we have two processes, one following one x 2 path, another following 2y 1 path. We will apply the first law of thermodynamics for individual processes. So let us consider 1x2. Here, the heat transfer is equal to the work transfer plus the change in energy, as it is following path 1x2. This is qx, this is wx, and this is del ex. Let it be equation 2. Similarly, for path 2y1, we have qy is equal to wy plus del ey. This is equation 3. If we add equation 2 with 3, we get this is your equation 4. So what is equation 4? Qx plus qy is equal to wx plus wy plus del ex plus del ey. Now, deducting equation 1 from equation 4, we get 0 is equal to del ex plus del ey. This implies del ex is equal to minus del ey. Now suppose it is following a different path. It is not following the path 2y1. It is following path 2z1 to reach at point 1. We can again apply the first law of thermodynamics for a closed cycle. In that case, we have to consider processes 1, x, 2 and processes 2, z1, and we can find out similar expressions what we have got when we consider 1x2 and 2y1, and again we can apply the first law of thermodynamics for a closed system undergoing a change of state, considering the path 1x2 and 2z1, and we can find out del ex is equal to minus del ez. Let this be equation 5 and this equation 6. Now from this, what we conclude that del ey is equal to del ez. So change in energy is remaining the same as we follow different paths. So there are infinite number of ways in which you can reach point 1 from point 2, and in each case the change of energy is remaining the same. So now we have successfully proved that energy is a point function just like your pressure, volume and temperature, etc. Energy is in fact an extensive property. So after this lecture, I sincerely believe that your concept about energy as a property of the system is quite clear. This would be extremely useful for all of you. Please do like and comment on this video, and don't forget to subscribe to the channel if you have not done this. Thank you.